Okay, dear student, how are you? I hope you are quite well. And in today's lecture, I am going to solve some problems which is based on Gauss law. Here we have written two numerical problems. Let me solve one by one. As you know, in Gauss law, the total flux passing through any closed surface is equal to Q upon epsilon 0. Q is charge enclosed inside the surface. Now here first problem is that S1 and S2 are two hollow concentric spheres enclosing charges Q and 2Q respectively as shown in the figure. The figure is shown here. First two questions have been asked in this problem. First, what is the ratio of electric flux through S1 and S2? And in the second, how will the electric flux through sphere S1 changes if a medium of dielectric constant phi is introduced in the space inside S1 in place of air. So look this figure. Here we draw it very small because of lack of space. So both spheres are concentric, means having common center, and the smaller sphere is said to be S1 and the bigger sphere is S2. Charge Q is inside the sphere S1 and 2Q charge is outer of S1 and inside S2. This is the situation. In this situation, first of all we have to calculate the flux passing through first sphere S1 and the flux passing through the second sphere S2. Okay, and then we have to compare these two fluxes. And in the second question, it is asked that what is the change in the flux passing through S1 if rather in place of air which is inside the sphere S1, it is replaced by a medium which is of having dielectric constant phi. Okay, phi. Now let me read this question in Hindi. दो संकेंद्रीय मीन्स कंसेंट्रिक स्फीयर्स दिए गए हैं. पहला छोटा स्फीयर जो है उसमें Q आवेश है, बड़ा स्फीयर जो दिया गया है उसमें 2Q उसके अंदर और S1 के बाहर. ओके, हमसे दोनों स्फीयर से पास होने वाले फ्लक्स का कंपैरिजन करना है. दूसरे प्रश्न में S1 से पासिंग जो फ्लक्स है उसकी वैल्यू में क्या चेंज आता है अगर हम इसके अंदर जो एयर फील्ड है उस एयर को रिप्लेस करते हैं किसी एक ऐसे डाइलेक्ट्रिक मटेरियल से whose dielectric constant is given here phi. 5. So let me try to solve it. Solution of question first. As you know, the charge within the surface sphere S1, as you know, the sphere is a symmetrical three-dimensional body, and it is supposed to be a Gaussian surface because charge encloses inside the surface S1. So from Gauss law, the flux passing through sphere S1, let this be phi 1, can be written as equal to capital Q upon epsilon 0. Okay, very simple, because only charge Q is inside this closed surface. Similarly, we can write the charge enclosed within the sphere S2. Sphere S2 is capital Q plus 2Q, that is 3q. Okay, definitely 2q is outside S1. It is not only this charge which is enclosed within the S2, but q is as well inside the S2. So the total charge enclosed within S2 means which is a Gaussian surface. So the total charge will be written here 3q. Now the electric flux passing through S2 can be written as equal to phi 2 is equal to nothing but charge total, which is 3q upon epsilon 0. Let me write this as second. हमने दोनों स्फीयर्स से फ्लक्स कितनी निकल रही हैं इसकी काउंटिंग की. वन थिंग हियर नोटेड, one should noted here one important point that not only 2q is inside the sphere but q is also. So in place of q upon epsilon 0 we should write here 3q, क्योंकि उसके अंदर जितने भी चार्जेस आएंगे चाहे वो छोटे स्फीयर में हैं चाहे छोटे स्फीयर के बाहर हैं, बड़े के अंदर तो ही हैं, क्योंकि स्फीयर S1 is inside S2, so the charge inside S1 will be taken into account if you take the charge enclosed within the S2. So the first part, let me write the first part, phi 1 upon phi 2, this is q upon epsilon 0 upon 3q upon epsilon 0, that is 1 upon 3. So we have phi 1 is to phi 2 is nothing but it is 1 is to 3. It means more flux is passing through the second sphere S2 and comparatively less flux is passing through sphere S1. Now we come to the second part of this first equation, which is how will the electric flux through sphere S1 change if a medium of dielectric constant 5 is introduced in the space inside S1 in place of air. As you know from Gauss law, phi E is nothing but it is closed surface integral of E dot ds. Okay. Here, if the dielectric medium is inserted here, this field will goes because of this charge will be changed, because the medium inside the sphere will change. So here we write it as something like that, E dot ds upon k. So phi E can be written as equal to q upon, rather than q upon epsilon 0, this is q upon epsilon 0 k. Since E dot ds can be written as q upon epsilon 0, so E dash dot ds can be written as simply E upon k. Here E dash is equal to E upon k. As you know, electric field is inversely proportional to the dielectric constant. So by inserting the dielectric constant of any value, the electric field due to this charge at any point on the outer surface will be changed, whose value is that one. So or you can say directly in place of on the right hand side, in place of q upon epsilon 0, we have q upon epsilon 0 k. This is the flux through phase first one, phi 1 dash. Now this can be written as phi 1 dash is equal to q upon 1 upon 5 q upon epsilon 0. So our flux will be equal to phi 1 upon 5. By inserting the dielectric material of dielectric constant 5 inside sphere S1, the flux after this insertion of dielectric material, flux passing through S1 will be equal to 1 upon 5 times the flux passing through S1 when the air is present inside. Okay. though in this way we have solved the first problem.